Okay, so in yesterday's lecture, what we have discussed? We have discussed about the SONET, right? Then different SONET architecture or SONET network, then different devices or components involved in the SONET network. Okay, then what is use and requirement of each and every devices in to form the SONET network. So all that point we have discussed in the last lecture, right? Now in this lecture we are going to talk about SONET frame structure, right? What do you mean by SONET frame structure? So basically, when any data that you need to transfer, right? So it must have some sort of frame structure. For example, I will try to make you understand with one very simple example, right? When uh, if you happen to write a card, right, postal card to someone, okay, then what you supposed to mention on that? तुम्हाला जर का एखाद्याला पत्र लिहायचं बरोबर आणि ते पत्र पाठवायचं तर फक्त तुम्ही पत्राचा मजकूर लिहून ते जर का पोस्ट बॉक्स मध्ये जर का तुम्ही टाकलं तर ते जाणार का डेस्टिनेशन मध्ये? नाही जाणार. सो फर्स्ट यू नीड टू मेन्शन टू whom यू वॉन्ट टू सेंड द कार्ड. त्याचं नाव, पत्ता, पिन कोड, बरोबर आहे. त्यानंतर तुमचा डेटा असणार, दॅट इज द पेलोड, म्हणजे मजकूर. तुम्हाला पत्रात काय म्हणायचंय किंवा कशासाठी पत्र लिहायचंय ते सगळं लिहिणार तुम्ही. आणि फायनली राईट टू whom इट इज रिसिव्ड, राईट. तिथं खाली तुम्ही लिहिता का नाही की आपला, आपली, विश्वासू, व्हॉट एव्हर नाव टाकता, म्हणजे कोणाकडनं ते पत्र आले हे पण ते कळतं. मग तसं एखादं डेटा पॅकेट जेव्हा तुम्हाला इंटरनेटवर पोस्ट करायचं असतं किंवा टाकायचं असतं त्याच्यात सुद्धा यू नीड टू मेन्शन द सम सॉर्ट ऑफ आयडेंटिफिकेशन ऑर द डेस्टिनेशन ऍड्रेस, बरोबर आहे. तर कुणाला पाठवायचंय पॅकेज तुम्हाला, त्याचं डेस्टिनेशन तुम्हाला माहित असणं गरजेचं आहे. सो यू नीड टू मेन्शन डेस्टिनेशन ऍड्रेस, राईट. देन देर विल बी अ पेलोड ओव्हरहेड, राईट. म्हणजे जे आधी कुणाकडनं सपोज आलेलं आहे, जसं फॉर एक्झाम्पल आता इथनं तुम्हाला सपोज मुंबईला पत्र पाठवायचं, ओके, यू हॅव मेन्शन द डेस्टिनेशन ऍड्रेस, यू हॅव राईट वॉट एव्हर द what you can say the thing that you want to convey to XYZ, so that all things you have written and you have posted that. Now when it will go to the Mumbai, it will not असं आहे का इथनं या पोस्टात उठलं डायरेक्ट मुंबईच्या पोस्टात जाऊन पडला, असं होतं का ते? नो, इट विल टेक सर्टन पाथ्स, राईट. इट विल फॉलो सर्टन पाथ्स. म्हणजे ते इथनं सपोज पहिले पुण्याच्या पोस्ट ऑफिस मध्ये जाईल, देन अगेन तिथे पुण्याच्या पोस्ट ऑफिसचा स्टॅम्प लागेल, तिथनं ते परत मुंबईच्या दिशेने फॉरवर्ड केलं जाईल. मीन्स व्हॉट, दिस intermediate points are nothing but the routers from one point to another point, from one point to another point, right? That means whether the packet is coming, right, already ते पंढरपूर वरनं आलेलं आहे, right, and it has to delivered at the Mumbai location. So basically it will take certain paths, right, and at each path they will add their what we can say address or their identification, right. I'm making to make it, I'm trying to make it simple so that you will understand it very well. Okay, so in that context or in that way, each and every packet or each and every frame must have data, right, must have destination address where you want to send that data. Then you must have some payload overhead, right. So all these things there should be that will involved in the frame structure of any. Okay, now the basic building block of SONET is the STS1 frame. Okay, the figure that you are getting on the screen, that is the basic building block of that SONET protocol. And all of you are aware of, as it is a protocol, though it is a working on a physical layer, but basically it also have some standardized frame structure. Okay, the length of the frame is defined by the number of bits it is possible to transmit in 125 microsecond at a clock rate of a network link. Okay, for different network they may have different clock rate, right, and whatever the clock rate of that network at in 125 microsecond, how much bits it can able to transmit, that defines the length of the frame. Okay, this is the generalized structure. So first you have a transport overhead, that is first three columns. Then you have a payload overhead, right? Then in that transport overhead, first you have a section overhead and line overhead. Then you have a payload overhead, and the pink colored boxes are nothing but data, म्हणजे तो तुमचा मजकूर, ती तुम्हाला इन्फॉर्मेशन पाठवायची, right? So basically this SONET frame have a two structure, transport overhead and synchronous payload envelope, that is SPE, that is 87 columns. Now what is the details of this SONET frame structure? So first 9 rows by 90 columns, that means it is totally forming the 810 octets in the frame. The frame is transmitted from left to right by row, that means row wise the frame is transmitting. The frames are transmitting 800 times per 8000 times per second. As you know, it's a time division multiplexing, so we have to measure the number, what we can say, the data speed in terms of with respect to time, because SONET uses the TDM technique, time division multiplexing. So the time given it is in the time units, that means microsecond or millisecond. So 8000 times per second every 125 microseconds, right? That means 8000 times per second and every 125 microsecond. Then this bit rate is up to 51.84 megabits per second or megabytes per second, right? That means 810 octets multiplied by 8000 times per second into 8 bits per octet. These many tremendous amount of data can be transmitted in over this SONET network. The lowest level SONET signal is called as synchronous. That means the lowest data rate signal is called as synchronous. The transport signal and the level 1, these are, once the scrambler is applied, it is known as optical channel level 1, that is OC1. Scrambler, you might have studied in your digital technique. What do you mean by scrambling technique and all that? Okay. And the lowest level synchronous digital hierarchy signal is known as synchronous transport module, that is STM level 1. That means depending upon the network, its clock pulse, its capacity, there are different standards and levels of the SONET frame that you can transmit, right? So you can transmit ST1 level, that is transport signal level 1, or OC1 or STM1. So basically STM1 is used in rest of the country, because if you talk about a USA, they can use the STS1 or OC1. We are using STM1, right? In our country, we are using STM1 technique. So this is about the SONET frame structure. Now we will discuss about the SONET rings. How different, what we can say, networks are formed, or they are, what we can say, arranged in a ring-like structure. That means a round shape structure from one network to another network, or from one node to another node, then from that node to some next node. That forms the ring of the SONET. Okay. Now this SONET or SDH can be configured either a ring or mesh architecture. Okay, that means different, what we can say, SONET networks can be arranged in the form of ring or mesh architecture. And the rings are the self-healing rings, because the traffic flowing along a certain path can be switched automatically to an alternate or standby path following the failure or degradation of the link. That means this SONET rings are self-healing rings. Means, for example, what it means, if suppose you can look at figure number A, that is the first one. If node A got failed, or node A got, what we can say, there is some fault that occurred in node A, then that node 4 can directly change its path to the node 2, and again it will continue to form a ring. That means it can simply exclude that faulty node, and it will continue with the communication after changing or switching an alternate node, right? Or simply it can stand by that path, okay, and it will acknowledge there is a fault in a node 1, and if again that node 1 will get in a working condition, then again it will continue with the ring. Okay, that means either it can switch automatically to alternate path, or it can remain into a standby mode unless and until that node will get into a working condition again. Okay, so that's why SONET rings are the self-healing rings. Okay, there is means if any of the node or any of the intermediate path, if that got disturbed, then also there will not be any effect on their communication. It will automatically switch to the nearby nodes. Okay, whatever the nodes nearby that are present in the zone, because see, each and every node is connected with each other. Okay, right? And so the previous node will automatically switch its path to the nearby node, and it will continue communicating with the further nodes. Okay, and this also can apply to network also. At network level also you can apply this concept. Okay, now there are two popular SONET and SDH networks, that is unidirectional path switched ring, that is 2-fiber UPSR, and 2-fiber or 4-fiber BLSR. Okay, these are the two popularly used SONET networks. Okay, 2-fiber UPSR or 2-fiber BLSR. These are the BLSR stands for bidirectional line switched ring, and UPSR stands for unidirectional path switched ring, right? And BLSR is bidirectional line switched ring, and UPSR is unidirectional path switched ring. Okay, so these are the two popularly used SONET and SDH networks, and its construction and its how they are arranged in a ring structure, that you can see in the figure number A and figure number B. Okay, so this is about the SONET and SDH ring. Now we will talk about the passive optical networks, that is PON network. Okay, what do you mean by this passive optical networks? Okay, then how it will useful to connect to the Ethernet or internet protocol. That means whenever you want to transmit some data onto the network, optical data that is in the form of light, but still if you want to transmit onto the network after converting into a electrical signal, so optical Ethernet, right? There is a concept named as optical Ethernet that come into a exist. Okay, whenever you want to communicate with the what we can say network or some sort of server, then optical Ethernet comes into a picture. Okay, so this passive optical network, then what are different elements of this passive optical network, then what do you mean by optical Ethernet? So we will discuss that point in the next lecture. For today we will stop here. Okay, if you have any query or doubt about the SONET frame structure, then you can ask me right now.